Hello, everybody, and welcome to the Seekers Twitch. This is our second part of our Decentralized Comms chat here with the wonderful Josh Dawes. Hey, Josh, how we doing?
Yeah, pretty good.
Doing good, good. Welcome. Oh my gosh, I'm so excited for part two. This is going to be a very, very wonderful evening, afternoon, or morning for you all tuning in now. We'll give you guys a couple of minutes to come on in. Feel free to give us some notifications in the chat. Give us a wave. Hey, how are you going? I see you all filling in. That's wonderful. How's your week been, Josh? It's Friendly Friday over in New Zealand. How's your week been?
Yeah, pretty good. It's been a busy one actually. Lots of various things coming out this week. Yeah. I feel like this is going to be a nice way to round it off. A bit of a chat and explore some interesting ideas, and looking forward to it. I think.
Yeah, definitely. What a perfect way to end the week. I mean, yeah, it's been a good week for me as well. It's been very, very busy over on the Seekers team and in our ecosystem as a whole. It's been pretty wild the last couple of weeks. So I feel like it is very appropriate to round it off with this chat, especially because so yesterday, if you didn't tune in, we had our network AMA, which was great, an opportunity to chat with our founders and lead delivery leads about what we've been up to. So that was really great. And a couple of questions were raised about people really wanting to know about the ins and outs of decentralized comms and how it really works, and really putting it in kind of like layman's terms so that the general person can understand, because it seems quite daunting when you first when you're first introduced to the idea. But actually, like I said last time, communication is something that we use every single day. It's so important in today's society, and the idea of decentralized comms is it's really one to sink your teeth into. So very, very excited for your chat today. But yeah,
there's also sort of like a lack of beginner content out there. Like when I was preparing for this, a lot of the stuff that I found sort of starts at step 2 or 3. And hopefully what we can do with this is give the overview at that level where it's accessible to people who are just starting out, but also maybe get into some of the deeper stuff and the questions. That's the goal.
Definitely. Oh, well.
Good to see you all piling in.
I see you all piling in. Hello. Welcome. Hey, so good to see you all. Love that. Yeah. Very, very exciting. Oh, actually, I was just thinking, yesterday, Josh, do you remember the Dr. Grobwart's ray guns?
Yeah.
So yesterday I was out at a gig, and there was the Weta Workshop were there, and I saw the ray guns in real life.
No way, huh?
It was very...
Weta do some pretty amazing stuff. Tell me about that. Well, I haven't actually heard about this.
They were transforming these people into like goblins and monsters and stuff. It was pretty crazy. They were terrifying the children. It was quite awesome. And they were giving people like scars. It was really cool. Like not actual scars, but like,
Yeah, I was going to say.
Yeah.
That's right, Captain.
Yeah, it's like because they've got a pop-up Weta Workshop here in Auckland, so they were doing something for that, so that was really cool. But it was cool to see the Grobwart guns that we have in our ecosystem IRL. I was like, oh my gosh, they weren't as colorful and wonderful as the NFT version, but it was quite cool. It was quite exciting. But anyway, I digress. I'm seeing a lot of folks in the chat saying POAP. Yes, you are right. That today we will have a POAP for attending. And Josh, you kind of became a bit of a local legend the last chat that we did, because you're now affectionately named in the community Chainsaw Josh. So you're welcome.
Other words, okay.
You're like, well, I could have thought of a better nickname, but I guess Chainsaw Josh is it.
I guess if you don't click on that, choose it for you, right? That's just how it goes. So Chainsaw Josh is perfect.
Yeah, I was like, okay, that's That's great. That's awesome. Great. So yeah, we'll maybe I'll wait and I'll give you all another minute to come on in, and then we will just get started into round two. Yeah, so very excited. Have we thought of any more decentralized comms puns from last time? Have we gotten better than send nodes, or is that all we have today, ladies and gentlemen? What is it? I think it's probably send nodes. That is, it's the winning decentralized comms pun.
It's hard to improve on the classics.
Yeah.
Out of curiosity, how many of you guys were here for the last one? If you've seen part one, say something in the chat.
If you're in part one, give us a hands up. Yes, thank you, Hypno Toad. I do recognize you. Oh, Sam, really? Just kidding. Oh dear. Great. Yes, it's so good to see you all again. You're going for that 4-poet moment. You want to get it all. So that's good. You caught the rerun? Nice. Yes, we did have this will be recorded. So yeah, for people that miss out, there is you can re-watch it again. And we're going to try and create this in like short form video, kind of bite-sized content so that you can get the TLDR of it. I always get the letters mixed up for that. Anyway, awesome. Some people are saying they're here for Josh. Some people are saying they're just here for the poet. I'm like, wow. I'm standing. I almost fell backwards. Oh my god, that's scary. Okay. Anyway, I digress. We've almost hit the 7-minute mark. Let's just get right into it. Ladies and gentlemen, I would love to introduce to you the one, the only. It is Mr. Chainsaw Josh Dawes. Yeah. Woohoo!
Alrighty, yeah. Let's take it away. Okay. So I think we'll start with a bit of housekeeping, like normal. So the goal of these is to make this accessible to anybody. That's what we're hoping to do, which is, especially towards the end of these talks, it's going to be a bit of a tough ask, but we're aiming for it. And that means that I'm really keen to hear back if what I'm saying doesn't land, if it doesn't make sense, or if I haven't explained something clearly enough. So please chuck that in the chat. There's a couple points during this where I'm going to pause and we'll see if there have been any questions through what I'm saying, and then if there haven't, we'll just carry on. And then otherwise we can hopefully, clear that up. I'm not necessarily an expert on everything that I'm talking about, so some questions I might not be able to answer if they're super technical, but I'll do my best. And then at the end of the talk, some of the more deep dive questions we'll tackle those then, whereas we'll just do sort of clarifying stuff during. And there was one more thing. I am going to assume that we've seen part one. So if there's a big thing that's not making sense, feel free to ask about that, and we'll see if we can fill that information back in as we pause throughout it, because these slides sort of carry on from the first ones. But yeah, that's all the boring bits. Right, yeah, so what we're talking about today is the opposite of a centralized communication system, which is decentralized communication systems, funnily enough. And we're just going to look at what's out there, what are the other alternatives to doing it the centralized way. And hopefully with that context, that'll help us to understand why we're doing what we're doing with the Sylo nodes and the Sylo network, and with the seekers, and help to explain why a lot of the more complicated stuff that we're doing is necessary, which is, yeah, quite a topic to get through. So a bit of a recap of what we've covered so far. Basically, centralized communication systems have a server in between the two people who are communicating. And that server stores a copy of all of the messages that travel between those two people. The thing about that is that copy contains, information about the peer review, and that's useful for targeted advertising. So the company who owns that server can use that knowledge about you to make a profit. And that creates a profit motive for intruding in your privacy, essentially. So it's the business model of these centralized systems that's the fundamental problem. The fact that they're centralized just allows them to take that look into your information. So you can sort of address those kinds of concerns with technical measures, things like end-to-end encryption. For example, WhatsApp and Signal both use that. And that helps, but there are other ways that these companies can still monetize the information that they know about you, even with end-to-end encryption. So that's not a silver bullet. That's not like a perfect fix. And so basically where we got to last time was that if you wanted to solve this properly and not have this situation where there's this profit motive to invade people's privacy, you'd need a system where users' data was under their control. You'd need a system that had a business model that let it scale up to the mainstream. And also you'd need to be confident that there wouldn't be an external pressure to change that business model in the future. So it would need to be sort of a sustainable way of providing the service to people that wasn't vulnerable to like a change in ownership, for example, of the company that was doing it. Which is a bit of a tall order. This is quite a tough challenge. So that's kind of what's wrong with the centralized approach. And so today we're going to look at 3 different other ways of doing comms, with the goal of understanding their pros and cons and why they might not be complete solutions either. That sort of sums up where we're heading. So the 3 areas that we're going to talk about are the 3 sort of categories of decentralized system that I'm going to talk about are federated networks, pure peer-to-peer systems, and then something I'm calling decentralized services, which in some ways is kind of a hybrid between the 2, but it kind of builds upon both of them and fills a little niche, as we'll see. I'm not claiming that this is like an exhaustive list. This is more like illustrative of what kinds of things are out there. So there's going to be tons of projects that I don't mention, tons of really good work that's not in this talk just because of time. And I probably should add as well that the projects that I do focus on, I've picked largely because I think they're good examples of what they're trying to do. So even though I'm going to be kind of critical of things here, that's not necessarily me saying they're bad. That's just like, looking at them and saying what's good and bad about them, trying to understand them more deeply. Yeah. So with that, I guess we can jump in. So if you've got a centralized server that's doing messaging, maybe for the sake of example, we'll talk about Facebook here. So you've got the Facebook server that stores all of your posts, all of your photos, all that sort of stuff in one centralized place. A kind of natural way to think about improving that is rather than having one server, you would sort of break up all of the work that the Facebook server is doing and spread it out among multiple different servers that are owned by different people. And so that's what's called a federated network. So anybody who wants to join in can run their own little server, or quite big server, depending on what you want to do, that provides all of the same services that a centralized server does. And these servers cooperate in order to provide the same kind of experience that something like Facebook does. So I'm going to zoom in on a project called Mastodon as an example of a federated network, but there are some others like Diaspora. There's a variety out there. And so the key thing is that each user chooses their own server when they sign up. So both Monty and I might be part of the Mastodon network, and we would both host servers. And then if you wanted to be part of Mastodon and see posts on that Mastodon network, you could choose to either sign up with Monty's server or mine, based on who you like best, like who you trust the most, who has the best record for, privacy or reliability or all of those sorts of things. And whenever the servers try and show you some content, like for example a feed, my server and Monty's server work together to provide that to you. Often when you want to see something on a social network, it'll actually come from a lot of different servers. And that just depends on where each of the friends of yours that you're getting posts from have their information. So that's a little abstract, a little high level. So let's get a bit more concrete. So if we think about like a Facebook feed, or in this case, a Mastodon feed, with Facebook, you would send a message to the Facebook server and say, hi, send me a list of posts, please. I want to see my feed. And that one server would do some thinking, figure out what to show you, and then send back a list of stuff to look at. That's fairly simple. But with Mastodon, it's a little more complicated because the data that you want to see isn't in one place. It's spread out. So if Monty and I used different servers, then if I wanted to see Monty's posts, my server would have to ask Monty's server what she has posted. And so there's this sort of cooperative process where I'll ask for the feed. So I'll say to my server, hi, could I have the feed? And then my server will coordinate with the other servers and collect everything that's relevant to what I want to see, and get all of the posts that are visible to me and have the right permissions for me to see them. And then once my server has all of that information, it can then sort and organize them and figure out which ones are relevant to me. So this is where things like curating your feed might happen. And then finally, that curated feed would be sent back to my phone. So the key thing here is that if Monty has set a post as private and her server is being good, then it just won't send my server that post because I don't have permissions to see it. So if Monty trusts her server, then all of her private content stays private. And the idea with a network like this is that people will be able to choose their own server, and that'll mean that the trustworthy servers, the ones that are, effective at keeping things private and not taking advantage of users, they'll become more popular. That's sort of the overall idea. And so there's a couple of good upsides to a system like this. Each server can only see a fraction of all of the user's private information. So at a fundamental level, it's better for privacy, because even if the server was completely nefarious and just wanted to monetize everything, it would simply be able to see less in total. And also, because users can switch server, you would expect that the bad ones would lose users and the good ones would gain users. So there's sort of this competitive situation where they're all trying to convince people to, work with them essentially to store their posts on their server. And that networks like this also come with the option of bringing your own server. So if you're really concerned about privacy, you can start and run your own Mastodon server, which means that you have full control over the computer where your data is stored. So if you're really privacy centric, you don't need to trust anybody else, so long as you're willing to pay the costs of running a Mastodon server for yourself. And then you can participate in that wider social network, but also know for sure that no one else is going to have access to your data. And in that sense, it's a really good solution. But where it gets sticky is when you try to think about what would happen if everyone used Mastodon. Can this actually ever replace something like Facebook? The essence of it is that bringing your own server isn't easy to do. You need to be fairly technical. And there's also costs associated with it, because you basically have to set up and host a server on your own computer, or pay for something like Amazon Web Services or Azure to have a virtual host somewhere in the cloud for you. So most people won't do that. That's a fair bit of hassle. And so fundamentally, people's data will still be out there under someone else's control. And if you imagine that this all scaled up to be the whole world and everyone was using Mastodon instead of, say, Facebook, then those individual servers that people are using would have the same profit motive that the one central server does in the Facebook situation. So in that sense, it's not a perfect fix. In practice, most people who use Mastodon actually sign up with the default server, and Mastodon, a nonprofit, provides that. So that's good. Like you could probably trust them. But again, it's that scalability concern from last time, like with Signal. If every user is a cost to the Mastodon nonprofit, can this become a big mainstream competitor to the advertising-driven business models of the mainstream services? And then I guess the third point is going to be useful for later. The Mastodon servers do a lot of heavy lifting on behalf of their user. So they store every post, like every image, every video clip, permanently forever. And then whenever anybody asks to see that stuff, their job is to serve it out. So they have a fair amount of storage costs, bandwidth costs. Basically, the cost per user for a Mastodon server is quite high. And so that's a factor that limits their ability to scale when they have this non-profit situation going on. Yeah, so I guess that sums the federated network options up. They've got some advantages, but they're not a silver bullet. Does anyone have any questions on that, Monty? Have you seen anything good in the chat?
No questions yet. All groovy.
Nice. Yeah, okay, so that's the first section. So we've talked about the federated networks. Let's compare that with pure peer-to-peer solutions for messaging. So we've already touched on these. We talked about them in part 1. And I think today what we're going to try and do is maybe go one step deeper and talk about some of the potential solutions that you can apply within a peer-to-peer context. So if you were sort of saying, I'm only going to solve this in a peer-to-peer way, what kind of clever stuff can we get up to make peer-to-peer better? Yeah, just to get some more detail there. So essentially, peer-to-peer just means that there's no server in the middle and the two devices communicate directly over the internet. But as we talked about last time, they have a couple of fundamental issues in terms of user experience. So those are the synchronicity or sync issue. I think I made up a word last time, so we'll go with sync for now. There's also discovery, which is finding other peers. And then there are some implementation concerns for mobile devices that we're going to talk about too. It's worth reiterating, though, that peer-to-peer is fantastic in the sense of privacy because all of your data is kind of mastered on your device. And so it's fundamentally in your control. Also, if you want to send a message to a particular person and you know who that person is, you can encrypt that information so that only they can read it. So even though you might have to send information across a network and someone else could potentially look at it, the fact that you know who the recipient is, you know which peer you're sending it to, means that everything can be kept private, even though that message might follow a route involving multiple other computers. So yeah, that from a privacy perspective, it's great. It's just that we have to solve these technical issues. So we'll look at each of these in turn now, along with one way that you might solve it within a peer-to-peer context. And we'll see how that looks. So the first one we're going to talk about is the sync problem. So this is essentially, in order for information to move between two peers directly, they both have to be online at the same time. So if I was going to send a message to Monty using a peer-to-peer protocol, if Monty's phone is off, I can't send a message and kind of leave it for her to read later. She's got to be online and her phone has to be listening for messages coming from me, otherwise they just won't get there. There's nowhere to sort of store them in flight. And so that's basically what a server provides, is a place to leave messages for someone else later. But you could also try and solve this a different way using just the peers in the network. And one solution using that is something called a gossip protocol. So that basically works like this. If I want to message Monty and she's offline, I might know other peers who also know Monty. So basically maybe we have like a bunch of mutual friends in common, if we're using like a social network example. And I know that if I send a message to Monty via one of our mutual friends, then that person can also deliver it on my behalf if Monty and the mutual friend happen to be online at the same time. So now any one of us can be online and Monty will still get the message. So I might send my message to Monty through 10 different mutual friends. And then if any one of those 10 are online, my message will get delivered when Monty pops up, when her phone comes back on. And so that would essentially solve the sync problem, because from Monty's perspective, that message is waiting and ready for her when she comes online. And from my perspective, I can send it and then forget about it, and I can just trust that it'll get there at some point. And this largely works, but there are two key downsides to it. The first one is that you have to rely on these other peers to behave altruistically towards you. They have to do something for you, basically for free, in order for this to work. And so it's not entirely for free, because there's kind of a tit for tat thing going on. You have to do someone a favor one day, they'll do you a favor the next day. So this isn't like a fatal problem, but it does mean that certain kinds of application don't really work this way. So if you ask someone, hi, I've got like 500 gigabytes of video that I want to send to Monty, most phones aren't going to be able to do that. And they're definitely not going to want to, because like that's your entire data cap gone for a month. You know what I mean? There's limits to what people will freely share, and that limits what you can do with this kind of tech. The other thing is that it's, from a sort of bandwidth perspective, it's quite inefficient, because if I could send this message through a centralized server, I send it once to the server and then again to Monty's phone, and that's sort of 2 hops. But then if I'm using 10 peers and any one of those 10 can deliver it to Monty, that's 10 hops, or plus 1, I guess, whoever sends it to Monty first. And so it's almost like 5 times less efficient to do it this way overall, which, it's not the end of the world, but it's worth knowing that these things are often less efficient than a centralized approach. Yeah, so that's the sync problem and how you might tackle it with a purely peer-to-peer mindset. The next problem, and this is one we've also discussed last time, is one that I'm calling the discovery problem. And so this is essentially how do peers know where to find other peers on the network. So mobile devices move. Like if you think of a normal commute, you'd go from your home Wi-Fi, you'd go to data, maybe your train offers Wi-Fi, back to data, and then the office. And so over that hour, you're in 5 different network locations, which means that it's often quite hard to know where to send a message across the internet. And that's illustrated here. You can see that the device used to be connected along this route, but now it's connected along this route here. Excuse me. The issue, the fundamental issue, the one that's very hard to solve, is that if both peers move at the same time, they have no way of getting back in touch with each other. If only one of them moves, they can sort of have a chat and figure it out. One can message the other and say, hi, I've moved, you should update where you think I am. But when both of them move together, they can just lose touch completely. And the related problem is when a new peer joins up for the first time, it doesn't know how to talk to anybody because it has no other peers that it knows the address of. And so there's a lot of technical solutions to this. I'm just going to touch on one of them. And so this idea is a discovery server. So each peer can publish their location to that discovery server for anyone else to look up. So you can almost think about putting like a post-it note up on a bulletin board, or putting your phone number in the phone book, something like that, right? And then anybody who wants to know where you are just needs to look you up in that address book. And because this is a server, every peer knows where on the network that server is, because it won't change. So the server can just say to everybody, hi, this is where I live. If you need to find out where somebody else is, come ask me. And this discovery server essentially solves this discovery problem, because if I lose track of Monty, all I need to do is ask the discovery server where she is. And then once we get in touch again, we can go back to peer-to-peer. So the only thing that my device is getting from the discovery server is how to reach Monty. We're not relying on it for storing anything sensitive like message contents. It's just about putting us in touch. And so in that sense, this is quite good for privacy, because it's taking the centralized server, but it's using it for only the part that needs to be centralized, as opposed to just storing all of the data in one place. So that's one way you might solve discovery in peer-to-peer. The main downside with this, again, comes with scaling. Somebody has to run this service and spend some money to provide it to the network. And so you again sort of come to this question of altruism. Could this scale up to encompass the whole world? Who would pay for the servers? How would you make sure they were reliable? All of that sort of thing. Excuse me. I think there's one more thing. But yeah, this is it. Okay, so there's one more point to mention on this. That discovery server would know some metadata about you, because it knows who is trying to reach who. So it's almost a perfect solution, but there are still some privacy aspects to it, although we're not really going to get into those. So that's like a peer-to-peer-ish approach to the discovery problem. But I think the third issue with peer-to-peer, and honestly the most challenging one from a sort of practical perspective, is what I'm just going to summarize as implementation issues. The way that mobile devices work, like their operating system, isn't very friendly to peer-to-peer applications. So the basic assumption that a phone operating system makes is that apps are only really active when they're open, like when they're being actively used by the user. And there are some good reasons for that. Like phones have limited battery life. So you sort of want to be able to tell apps not to waste battery when the user isn't using them. But what that means is you often can't write an app on a mobile device that can passively participate in things like gossip protocols in the background, because the OS will say, hey, why are you using resources? That's not cool, and just shut that down. And they don't really, protocols like that need to kind of be passively online so that stuff can happen and they can hear about it. It doesn't really work. A gossip protocol doesn't really work if the app is only running when it's open and in the user's hand, because that's such a small fraction of the time. Yeah, so that's that issue. There's also something called network address translation, or NAT. And this is honestly a little bit out of my depth, the technical detail. But basically, the kinds of networks that mobile devices are part of when they are out and about, like data on your phone, roaming networks, that sort of thing, they can choose what kind of traffic is allowed to reach your phone. And they tend to just disallow the kind of traffic that peer-to-peer software needs. So it can often be quite hard to actually get the address of a peer going through a NAT process, depending on the network that your phone is on. So this one here, I probably know the least about of these three, but it's also one of the most fundamental ones that make this very hard to do. And so when you take these things together, apps that can ask a fixed address, like a central server, for updates work much better with mobile phone devices than these sort of peer-to-peer style apps that are always running and need to be able to reach peers directly. And what this means is that the user experience with purely peer-to-peer apps, you can sort of get around this all to some extent, but the end result is that the user experience can't really compete with this sort of more centralized design, in part because of the way that the operating system is set up. So that's the peer-to-peer section. And that was probably the toughest content so far. So I think this would be a good time to pause and see if anyone's asking good questions. What do you think, Monty? How are things looking?
Yes, there were a couple questions in the chat, so I think this is a very good time. We had one about, sorry, let me just quickly scroll up. When people, there we go. When people are using Amazon Web Service to host their node, the private messages stored on Amazon hard drives or drives within the server located at home?
Okay. Yeah, so that's a good question. So essentially, those messages are stored on a computer in a data center that's owned by Amazon. The technical details of this are quite complicated, so this answer is going to be kind of high level. But essentially, you can set those computers up in a way where only the owner can read certain information. So it's if you do it right, you can encrypt the sensitive stuff so that it doesn't matter whose computer you are running. This is a bit of an incomplete answer.
Computing.
Yeah, I think I'm opening a bit of a can of worms there.
Right.
I might park that one till the end if that's okay. Do you think you could flag that one, Monty, so we can come back to it?
Yep, definitely can do that. No problem. Is there anybody else that has any questions at this point in time? I'll give you a couple of seconds. Cool. Oh, I think I actually had a question. So with that gossip, the gossip protocol, does that mean that so when you say like, you're sending it to X and then instead you're sending it to like mutual parties, does that mean that the mutual parties can also like read the message? Or just that like it'll be stored on their...
Good question. Yeah, so in this case, the answer is no, they can't read it. Because I know exactly who I'm sending it to, so I know that I'm sending this information to Monty, all of the sensitive stuff can be encrypted for Monty. So even though the data is sitting on someone else's phone, to them it just looks like zeros and ones. There's no way for them to recover the meaning of the information unless they have something called Monty's private key, which is from the first talk, we sort of had that locked box analogy. So basically, in the same way that end-to-end encryption puts the information inside a locked box while it's moving through the server, the same kind of thing can apply with gossip protocols. So you can send the sensitive stuff in a way that's hidden from all of the in-between peers.
Right. Okay, cool. Sweet. Yeah, that was just my question. I didn't want to interrupt. So
No,
cool. Anybody else? 5, 4, 3, 2, 1. All right. I don't see any other questions. So if there's anything else, I'll pop them up in the next break, but carry on.
Okay. Yeah, so let's see. So that was a lot of sort of bits and pieces of sort of disconnected information. So maybe we should try and draw some common threads out of this and see what we've learned. The fundamental thing is having your data on your device is the best for privacy. You have the most control in that situation. But as we've seen with these peer-to-peer examples, there are some problems with how software works that you can only really solve well with the server. But as we saw with that discovery server example, you don't need to do everything using a server, and you can design services, small kind of utilities that solve the problems with peer-to-peer in kind of a minimal way. And if those services do nothing else, and they only focus on that problem, you don't need to spend a lot per user to offer those services. And also, they, by design, leak very little information about the user who is using those services. And so this sort of leads into the third category of decentralized communications tech that I'm going to be talking about, which is decentralized services. If you design these services right, you can basically do peer-to-peer plus, where most of the user experience problems of peer-to-peer are solved by these services. And it means that you get, you can have your cake and eat it too. You can get the best of both worlds here. You get both user experience and privacy. So this category of decentralized tech, there's a lot of examples of it throughout the space. And there are also some of the most technical things you can read about in decentralized comms. They're sort of the furthest from what people normally experience when they use the web. So rather than getting into a full analysis of what's available with these, I thought I would just deep dive into one of them, which is sort of a precursor to the kind of service that we're working on at Sylo. So we're doing something in this category. And what I'm about to show you isn't exactly what we're doing, but it's something that will help you to understand what I will explain in future talks, which is what we are doing. It's kind of the first half of the story there. So here's an example of a decentralized service that will effectively help to solve those peer-to-peer problems. And I'm going to call it Event Relay. So the way that this works is it does exactly what's needed to move information between two devices using a central server and very little extra. And in doing so, it solves some of those problems. So let's just walk through what happens when an event relay is done. That's probably the easiest way to explain. So the situation we're in is Monty's device over here, Monty's phone, wants to send me a message, but I'm offline, so peer-to-peer directly won't work. And so essentially, Monty can package up her message into an event, which is the thing that's going to be sent through this relay service. And in that process, she also encrypts the event so that only I can read it. So even though it will be on this server in the middle for a period of time, it's opaque to that server. It's just zeros and ones. Once Monty's done that, she hands the event over to the relay service provider. She says, hey, this is for Josh. Please hold on to it for me. Bye. And she goes offline. So that's the end of Monty's involvement in this. Sometime later, maybe like an hour, maybe a day, whatever, my phone comes online, and I want to know what's happened. So I call up the event relay service and I say, hey, are there any events for me? What's happened? Tell me what's been going on. And the event relay service has this event from Monty, so that's passed on to my device. Because it's for me, I can decrypt it. And so now I have the information that Monty sent me. I've got the message. And now that I've collected it, the event relay service doesn't have to care it doesn't have to care about that event anymore. It knows that it's been delivered, its job is done, and so it can basically just delete that event. And it may as well delete that event because it's meaningless to the relay service because of that encryption. So all this really does is stores kind of in-flight messages. And so you can imagine a peer-to-peer app that might use this service where it first tries to reach me directly. So Monty's phone would try and establish that direct connection with my device. But then when it can't, it falls back on the relay service and says, I tried to reach Josh, but I couldn't, so please pass this on to him when you get the chance. And that'll mean that no matter whether or not I'm online, from the perspective of my user experience, either way, I turn my phone on and Monty's message turns up. It just happens to go through a different route. So this is an example at sort of a high level of what I mean by a decentralized service. And yeah, like I said, this builds into the incentivized event relay that's talked about in the white paper, but we'll get there next week. So in a little more detail, this event relay solves the sync problem. If Monty goes offline after the message has been sent, it still gets through, so tick. Event relay also solves the discovery problem, because even if Monty loses touch with me, like she doesn't know what address my phone is at, she can leave an event with the event relay service that says, hey, you can reach me at address XYZ. You can find me here. Monty knows where the relay provider is. I also know where the relay provider is. So even though we don't know how to find each other, we can both find that midpoint, and that lets us reestablish peer-to-peer contact. So in that sense, this is great because it gets us through those user experience problems while also giving us the data privacy benefits of peer-to-peer. And then I suppose the main thing here that we still need to think about is that we're still relying on someone to provide that event relay service. You know, there's bandwidth being used, there's data being stored, a computer's running somewhere that needs paying for. So someone's got to provide that service. And we need to think a little more about who they are and why they might do that if we're really going to scale up to the mainstream with technology like this. So in particular, we need to think about why they're motivated to provide that service, why they're motivated to make that service really reliable, because centralized communication is very, very reliable, and you need to be able to match that with a decentralized approach if you want to compete in terms of user experience. And finally, as well, you need to make sure that the availability of that service will scale. So if the network gets twice as popular, you need twice as many event relay service providers, and you need a mechanism for making those two line up so that everyone can still do their thing when the network grows. And these questions lead into the ideas of incentivization that we're going to cover in the third and fourth talks. Yeah, so that's the end of my slides. Keen to hear questions either about that last piece or just more broadly about the whole talk. Yeah, I think that's what I've got. How's it looking, Monty?
Cool, awesome. Yep, nope, it's looking good. Looking good in the chat. We're getting some education going. Yes. Dita is wondering why. What is the point of all this? And it looks like a bunch of you have been coming to the chats because the answers are very, very good. Very, very informational. All right. Have we got any questions? Oh, here's some. Here is one. Is the encryption something that is automatic?
Mm-hmm. Yeah, okay. That's a good question. Just trying to get that.
Here is or there is also this one that makes it so how can a message be encrypted in such a way that only one key can unlock it without knowing anything about that key? How can person A encrypt a message, build a lock? Oh, it won't show the whole thing.
Yeah, that one. Yeah, I think I can answer T-Doge and Thor in the same sort of explanation. So I'll start with Thor because I think laying that groundwork will help answer the automatic question. So, okay. Summarizing quite heavily. In encryption, there are sort of two important ideas. So there's the idea of your public key and your private key. So your public key is a string of characters, some information that basically identifies you. So it lets you say, hey, this is who I am. And if you want to encrypt something so that only I can read it, you can use my public key to do that. And that means that if I have Monty as one of my peers, that means that I know her public key. And if I know her public key, I can then encrypt the information so that only Monty's private key can decrypt it or unlock it. So you can share the public key with anybody you want, because that doesn't give you any ability to read the information. It's only the private key that needs to be kept secret. And so that information, Monty's public key, is automatically stored inside my peer-to-peer app, right? So in the friends list, there's a list of my friends' public keys as well. And that can mean that if I want to encrypt something for any of my friends, it can automatically just look up their public key and then do the magic math that makes it encrypted, and then send the encrypted stuff to Monty. So this is all hidden away deep in the code and quite complicated and very heavily reviewed libraries, basically. Cryptography code is very important to do it exactly right. So people don't tend to write their own. You tend to rely on sort of public open source, high quality stuff. So that's an overview of the mechanics of it. I think that in general, I feel like that is probably an unsatisfying explanation thought, because it's quite high level. I'm trying to think of a good place to start. I'll tell you what, if you're interested in looking into this more, have a read about the idea of a one-time pad. It's about the simplest kind of encryption that you can talk about that is still very strong and fundamentally works. And it might give you a sense of how that works in a sort of more hands-on kind of way than just me talking about it. So that would be my advice. I want to get into it.
A one-time pad?
One-time pad, like pad of paper.
Pad, okay, cool.
Yeah.
Perfect, just to clarify that. Awesome. Yeah. Perfect. Let's have a little look.
Yeah, for sure. This stuff is really technical. So if you haven't touched it in 6 months, you're like, what on earth is any of this? It's cool. Yeah, Caesar Cipher, that's a good suggestion too. That one's, I need to remember how that one works actually. I think that the one-time pad will be closer to the keys. You can do a Caesar Cipher that kind of muddles the message. Oh no, yeah, that's also a good example. Get a bit off track there, but yeah, I think that's also worth looking at.
Cool.
How else are we doing?
Yes, are there any other questions? Comments, questions, queries from the chat? Feel free to post them up now, and we will do our best to answer them. And when I say we, I mean Josh, not me. I am merely the student. I am nowhere near the teacher. There is so much to learn, and every time we do these chats, I learn a lot more. So thank you very much. And I'm even, so cool.
Yeah, it's a lot to kind of process in a talk. You know what I mean? It's the sort of thing where you'll go, oh, hang on, about an hour after this, once it's all kind of settled. So.
Definitely. And as well, if there are any other questions that you've thought of after the fact and you want to ask Josh, feel free to post it out in the Discord, and I will get that over to him and have a little look. So, and Josh, do you want to give a little bit of a description of the next talk that we're doing as well? A little bit of a teaser?
Yeah. Do you want to chuck the slides back up? Yeah, okay. So if we're thinking about this question here, sort of how do you motivate the person providing service? key thing is that when you're relying on strangers to do something for you, you don't necessarily trust them. And that might mean that they might be actively nefarious, like they're trying to do something you don't want them to do. Or it could just mean that you don't have any particular reason to think that they'll be reliable, right? Like they might just take the day off and they might, because they're strangers, they could be anybody. You've got no reason to think that they're reliable. So these protocols that rely on altruism work because there are plenty of good, cool, techie people out there who do this stuff either for fun or out of a sense of like improving the world. And that's awesome. That's the reason we have a lot of this cool tech to start with. But if you want this stuff to go mainstream, you might need to set things up in a way where the only thing you're relying about the people providing this service is that they like money, right? If you could set up a situation where it just made financial sense to do the right thing and set up this pro-privacy service, you'd have a lot more confidence that Joe Blog off the street is going to do the right thing in terms of privacy or provide a high-quality service. And so that's the idea of incentivization. And that is where things like the blockchain come in, because you have this kind of environment where you can run code on chain and you don't have to worry about whose computer it's running on. You just know that the answer will be correct. No one's going to lie about what the outcome was in order to affect what's happening. So it's really this sort of unique setting where you can set up a system for incentivizing things that lets you scale decentralized comms bigger than you can with just pure altruism. I guess that's the summary. There's a lot to unpack in that, so I don't expect that to make a ton of sense until we get into the technical detail.
Cool.
But I think that's going to be largely where the next one goes.
Awesome. So if that tickles your fancy, then the next chat is going to be for you. So that will be happening in the next fortnight. So we're gonna keep doing these fortnightly. So in 2 weeks' time, we will be back with Josh the Chainsaw Dawes for part 3, which will be wonderful. Josh, now is the very sticky question I have for you. What is the secret word going to be for this week's chat?
Oh, that's a tough one.
We didn't get a recurring theme like chainsaw, and you just chose my name, so it wasn't as we didn't have an exciting metaphorical human,
No. How many letters can it be?
It can be anything.
I was gonna say decentralized, but then people are gonna get angry about whether it's an S or a Z.
True. Well, I tell you what, you could do decentralized and not tell them whether it's a Z or an S, and then they can go into Discord and I can just say yes or no.
Yeah, event relay, go on, Doge. That's a good one. Everyone can spell that.
There we go. Doge was listening. Yeah, so they're like, event relay. Perfect. They were definitely listening. Awesome. So if you are on this chat, the wonderful 47 of you, feel free to go into Discord, open a ticket. We want event relay, and Som will be sending off that poet for you. I almost forgot last week. Did you claim your poet last week, Josh?
No, I need to get. Well, I guess I'm too late now. I'm not sure. I missed that.
He was never there. There is no evidence on the blockchain that Josh was there at his own chat that we made a whole poem for.
I'm proof I did that talk.
There is no
proof. Now.
Awesome. All right. Well, wonderful. Thank you so much, Josh, for spending time with us today and giving us the down low on decentralized communications. This one has been my favorite so far. So let's see what happens in 2 weeks' time. I'm super excited. Thank you, everybody, for coming along. Thank you for your questions. Everybody's saying thank you, Josh. Thank you, Chainsaw. That's wonderful. And we will see you in 2 weeks' time. So let's continue the chatter over in the Discord. I will be there all day. So let's do that. Cool. Thank you so much. Bye, everybody.